Math 1108, Section 7.1, Rational Expressions and Restricted Values. A rational number can be written in the form p over q, where p and q are integers and q is not equal to 0. Examples, 2 over 3, or 2/3, negative 7/4. Terminating decimals, such as 45/100ths or 0.45, are rational numbers. They can be written in the form of an ordinary fraction. Repeating decimals, such as 0.1666 and so on, those are also rational numbers and can be written as an ordinary fraction. A rational expression is an algebraic expression that can be written in the form p over q, where p and q are polynomials, and the polynomial q cannot be 0 because division by 0 is undefined. A rational expression may have one or more restricted values. Consider the rational expression 2x plus 1 divided by x minus 2. Since division by 0 is undefined, the x value that causes the denominator to be 0 cannot be included in the domain for that rational expression. For this rational expression, x equals 2 is the restricted value. Equivalently, you can just say that that for that rational expression, x does not equal 0. In these examples, let's find or determine the restricted values. For this rational expression, the denominator is x plus 4, so we can just say x plus 4 is not 0, so the restricted value is negative 4. Or equivalently, we just say x does not equal negative 4 for this one. This denominator, x squared plus 3x minus 10, we can factor that, and then the factors can help us determine what the restricted values are. So x plus 5 times x minus 2 does not equal 0. So x does not equal negative 5, and x does not equal positive 2. In other words, negative 5 and positive 2 are the restricted values for that rational expression. This rational expression, the denominator x squared plus 16, as long as x is a real number, it can never be 0. So this one has no restrictions, no restricted values. I'll just write no restrictions. Okay, let's simplify the following rational terms, either the rational numbers or the rational expressions, and identify restricted values. 14 over 21, think of that as 2 times 7 over 3 times 7. 7 divided by 7 is 1, so 14 over 21 simplifies to 2/3. Negative 16 over 110, you can think of this as negative 3 times 22 divided by 5 times 22. And 22 divided by 22 equals 1, so this rational number simplifies to negative 3/5. For this rational expression, we can factor the numerator and the denominator. The numerator's factors are x minus 2 and x plus 1. And in the denominator, the two factors are x minus 2 and x minus 1. The common factors are x minus 2, so those cancel. This simplifies to x plus 1 over x minus 1. But the restricted values are determined by the original expression. One of the restricted values is 2, so we say x does not equal 2. The other restricted value is positive 1. For this rational expression, we'll factor the numerator. The numerator factors to x minus 8 and x plus 4. And the denominator, x squared minus 64, the two factors are x minus 8 and x plus 8. X minus 8 divided by x minus 8 equals 1. So the rational expression can be written in lower terms, x plus 4 divided by x plus 8. The restricted values, though, are determined by the original expression, so the restricted values are 8 and -8. Okay, in the next part, before two rational numbers or rational expressions can be added or subtracted, they need to have a common denominator. The least common denominator, LCD for short, of two fractions or two rational expressions is the least common multiple of the two denominators. So for these expressions, let's find the least common denominator for each pair. In this first pair of rational numbers, 6 over 7 and 8 over 5, 7 times 5 is the least common multiple of the denominators. 35 is both a multiple of 7 and a multiple of 5. For this one, let's use the prime factorizations of the denominators to find the least common denominator. The prime factorization of 12 is 2 times 2 times 3, and the prime factorization of 18 is 2 times 3 times 3. And so the least common denominator, or least common multiple of those two denominators, must have two factors of 2 in it. That is the most number of times that the prime factor 2 appears in the factorization. So the least common multiple of the denominators must have 2 times 2. This denominator has a factor of 3, and the other denominator has 3 times 3. So the least common multiple of the denominators must have 2 factors of 3 also. So when you multiply 2 times 2 times 3 times 3, you get 36. And just observe that 36 is a multiple of 12 because 12 times 3 is 36. And 36 is also a multiple of 18 because 18 times 2 is 36. Okay, for these pair, we have two rational expressions, so we'll factor each one of those. This denominator, x squared minus 3x minus 10, the factors are x minus 5 and x plus 2. The other denominator has factors x plus 2 and x plus 1. So the least common multiple of the denominators must have all of the factors that appear in those denominators. So x minus 5 is in the least common denominator. X plus 2 appears in both, but in the least common multiple, it only needs to appear once, so x plus 2 is a factor. And then x plus 1 is a factor of the second denominator, so in the least common denominator, it must also appear as a factor. Okay, we'll spend a couple of minutes adding and subtracting rational numbers and also rational expressions. Okay, before you can add or subtract fractions or rational expressions, you have to have a common denominator. In this first example, 17 over 5 plus 13 over 6, the least common denominator is just 5 times 6, which is 30. So what we can do is we can multiply 17/5 by 1 in the form 6 over 6, because the common denominator is 5 times 6. We'll add that to 13 over 6, but we'll multiply 13 over 6 by 1 in the form 5 over 5. And then we'll do the arithmetic. In the numerator, 17 times 6 is 102, and the denominator, 5 times 6 is 30. We're adding that to this product. In the numerator, 13 times 5 is 65, and the denominator, 6 times 5 is 30. And when we add those two fractions, which we can now because the denominators are the same, we get 167 divided by 30. Well, I'm going to do one of the subtraction ones. This difference of fractions, notice that the least common multiple of the two denominators is 42. 42 is a multiple of 14 because 14 times 3 is 42. It's also a multiple of 21 because 2 times 21 is 42. So what we'll do is we'll multiply 9/14 by 1 in the form 3 over 3. And we'll multiply 5 over 21 by 1 in the form 2 over 2. And then we'll do a little bit of arithmetic. We get 27 over 42. 9/14 times 3 over 3 is 27 over 42. And then we're going to subtract 10 over 42. And now that the denominators are the same, we can subtract one fraction from the other, and we're going to get 17 over 42. Okay, we'll start on this sum of two rational expressions. Let's find the least common multiple of the denominators first. If we look at the numerical factors 3 and 2, we can see that 6 is the least common multiple of 3 and 2. The denominator on the left has x squared and the denominator on the right has x. So the least common multiple of those is x to the second. And similarly for the other variable y, y and y squared appear. So y squared is the least common denominator. And so if we write down the least common denominator, 6x squared y squared, we'll determine what we need to multiply the numerators by. Okay, so this denominator over here on the left, 3x squared y, we would have to multiply that by 2y to get this least common denominator. So that means we need to multiply the numerator 5 by 2y. And then over here, this denominator, 6x squared y squared, in order to get that from this denominator, we would have to multiply 2xy to the second by 3x. So we'll multiply 7 times 3x. And then we can do a little bit more arithmetic. We'll just go ahead and write the single common denominator, 6x squared y squared. And then 5 times 2y is 10y. And we're adding that to 7 times 3x, which is plus 21x. So that's the end result of adding those two. Okay, for the next part, we'll do the bottom one here. We want to find the least common denominator, so we're going to factor each of the denominators. This denominator, the factors are x plus 4 and x minus 2. And the other denominator, when we factor it, it's x plus 5 and x minus 2. So the least common denominator is x plus 4 times x plus 5 times x minus 2. So what we have to do in this one, this denominator, x squared plus 2x minus 8, and then the numerator is 2x, we would have to multiply by 1 in the form x plus 5 over x plus 5, because x plus 5 is the factor missing from this denominator. And then we're going to add that to the other rational expression, 14 over x squared plus 3x minus 10. For this one, we have to multiply by 1 in the form x plus 4 over x plus 4. Okay, then the common denominator is just x plus 4 times x plus 5 times x minus 2. So if we multiply 2x times x plus 5, we get 2x to the second plus 10x, and then plus 4 times x plus 4 is plus 4x plus 16. And then simplify the numerator a little bit by combining the 10x plus 4x.